Good morning, good afternoon, or good evening, depending upon where you live around the world. I think I've gone knobby. I have attempted, and I'm now wondering whether I've gone down another bloody rabbit hole about making this jig. Knowing the functions I want it to be capable of, I took the base model which we had here, realised that there were physical or mechanical issues with it, and proceeded to make iteration number 2. Now, what we've got here is lots of knobs. I'll hide this one. Just a moment. Hide that. We've got a lot of knobs. We've got 2 on the back. What are they for? We've got 1 on the front. What's that for? We've got 2 on the side here. What are they for? And 1 on the front here as well. Each play its role in clamping or securing the jig. This one is the sole knob sandwiching the actual steel hub in place. It can be moved in and out slightly to accommodate various widths or depths rather of the steel hub itself, and by tightening the nut or the knob it can pull in, clamp, and is guided for its location on a couple of pins. Reasonable enough. Going back to the rear of this jig, we've got these 2 bolts or knobs here that, if we turn the same amount, will mean that the carriage or the base here can move back in parallel once it's all set up, of course, and this one here pushes against it once we've turned those knobs to put pressure on it so that there's no jiggling of the base plate, and these 2 here on either side clamp it down so that it is mechanically rigid or secure. And of course these little bits here probably need to be expanded a little bit so that it can be secured, bolted down to the drill press table. Is this a lot of effort to go to create this jig for the holes for the struts? Well, I suggest it's possibly a little bit more complicated than I thought, but remembering we went from the first iteration to this because we're accommodating a second axis of movement, whereas prior to, the axis or rotational movement was all that the jig was accommodating. The one that we talked about, that was, I took the idea from Brian Proctor for his model wheels. This now is much more involved because of the linear motion backwards and forwards to get our position up and down on the hub. So by necessity we've had to complicate it, but I say complicate in that there's more involved to get to this stage, but really that's just chunks of custom wood or nice seasoned wood or timber that you can use and create from your bench saw or drop saw, your compound motor saw. There's nothing actually complex in its construction. It's just a few blocks of rectangular component screwed and fixed together. The only reason I'm showing this in white at the moment because I'm not too sure what we're going to be doing with it. But this white here is just the reinforcing for the back plate, so when it's at 90 degrees and it holds it rigid. This plate here likewise is just, you can see it's not very complex, and clamps up against the tube. It just floats. doesn't even have to be this big really, but I thought it would be a little bit more logical to have this be able to be moved and to accommodate any variance in our hubs. Equally, just make another top for this and insert it instead of this particular part of the jig attached to here. You could have a second one if you wanted a different depth, but at the end of the day I can't cater for those variances, but this is what I'd come up with for no other better reason than it was just a direct extension from the previous jig. Can't see too many shortcomings in this. I realised that I needed these knobs because I can't ideally clamp down onto something and then adjust it. The base needs to be rigidly affixed to the drill press table, but this one needs to be able to move, so it can't be clamped as it normally would have in the previous iteration of jig. So a couple of knobs or a nut, just loosen it with a socket or a spanner, a spacer possibly, washer just to span the slot, loosen, move these back the same amount of rotations. So maybe you want to turn it 10 times, that'll be maybe 10 millimeters. Check for your sizing on here, adjust appropriately, so to the half turn, quarter turn, whatever you decide. Move this one just so that it puts pressure on these two rods or bolts. Clamp it back down, rotate, push the drill on the drill press. A little bit of faffing around, yeah, but if you want to build with a certainty of accuracy, or you don't want to have to be constantly being concerned about the inaccuracy at the time of constructing the components. And I think this is not a bad iteration of a clamp that can accommodate our rotary or radial movement and our lineal movement. We don't have to worry about any movement this way. That's why the base is clamped down. Okay, well that was a short one, wasn't it? But I did wonder when I was looking at it whether I had gone down another blind alley or overthinking it. But is the possibility of underthinking it also an issue? I think so. And at this stage I am going to leave this probably as it stands and progress forward with the other versions of the hubs. I've decided to have a wee look at a couple of different versions of hub and what implications it has for us. Not because it's any serious consideration, but rather I'm finding that the more I do, the more ideas crop up, or more observations crop up, and they may help when we come to build the dome itself. More knowledge rather than less. It's a bit like I was saying with the when I was talking about the sheer number of angles that can be found within a dome if you look hard enough. It's a resource. So even though it may be something that you'll ultimately put aside and not use, understanding them issues may be beneficial. Or not. Okay, leave it there. I'll see you in the next video. Okay, bye.